gases, what must happen in order for something to dissolve? Now, it's actually kind of interesting to think about this. Let's think about salt and water. Now, you know water, H-O-H. Well, except you know that water is not linear, right? What is the geometry of a water molecule? It's bent. That's exactly right. So if we really wanted to show the molecule with its geometry, we might show it like this. There's our water molecule. Now, because it's bent, we went on to learn that there was an uneven distribution of charges. What did we say that meant about water? What did we call that when a molecule had an uneven distribution of charges? Okay, we called it polar. And you can have polar covalent as the bond types, absolutely. The molecule as a whole, we would refer to as a polar molecule. So water is a polar molecule. Now, of course, you drop in table salt, NaCl. Now, in your shaker, the salt has as a solid sodium chloride. One sodium, one chlorine. That's a neutral compound. Sodium forms a +1 ion. Chlorine forms a -1 ion. Now you take it from your shaker and you drop it into the solution of water. And then it dissolves. But have you ever wondered why it dissolves? How does it dissolve? Well, here's what happens. The water molecule, which is polar, comes up to your sodium chloride, which is ionic. What does it mean that it's ionic? Well, it means that the chlorine has taken the negative from the sodium, and the sodium has become positive as a result. And because it's an ionic substance, you find that the water is actually able to squeeze its way between the chlorine and the sodium. And it's when water squeezes between them that they break into their individual ions, and now they are dissolved in that solution. Water by itself, not a solution, didn't have anything in it. Once you add the salt to it, water squeezes between the two ions. Because of the polar nature of water, it's able to separate the positive sodium from the negative chlorine, and then the salt becomes dissolved. But it takes a moment for that to happen, because the water has to find its way between the sodium chloride. And what you find is the more salt you dissolve, kind of the slower the process, because there's fewer water molecules that aren't already taken. And eventually you get to a point where there's no more water molecules available, and yet the salt will continue to dissolve, because here's what starts to happen. The water molecule between one salt that's dissolved between a sodium and a chloride will actually see, not see as in with their eyes, but functionally what happens is the water molecule basically says, look, I'm going to leave you and come over to these guys. And what happens as a result then is that my sodium and my chlorine that previously had a water molecule between it no longer does. And so this does what's called precipitate out. It re-solidifies once the sodium and the chlorine can come back together again. So as you pour more salt into your solution, the salt continues to dissolve. but some of that salt will fall out of solution, or what we call that is precipitate. A precipitate is the solid that comes from a solution. Usually forms on the bottom. If you keep adding salt and more salt and more salt, eventually you get this little slushy pile of salt at the bottom of your glass.